Hi everyone, Siddharth here. In today's discussion, we are going to talk about Spark and few of the key concepts like architecture and filter pushdown. Let's get started. So the first thing that you see on your screen is the architecture of Spark. Spark is kind of a distributed framework, so that means it works on a master and slave configuration. In this kind of a configuration, you will have a master controlling multiple slaves in the network. Spark can be installed in multiple modes. You could have a client mode, a cluster mode, and then a standalone mode. Now, the visual that you see on your screen is basically a client mode. In client mode, you can think of this mode as, let's say, a user which is sitting on his laptop and trying to submit his code to the cluster. So he will use a software called a Spark Submit, which is the blue block you see on the left-hand side. Now, your program is called as a driver program. You submit your code using Spark Submit software, and this code goes into the cluster. The first node that it touches is the master node. So master tries to go through your code and the data and understands that your code needs 3 executors. And then it decides in which slave nodes it should start those 3 executors, right? So in your screen, you can see that 2 executors got started in slave 1 and 1 executor got started in slave 2. What is an executor is something that we will figure out later. But as of now, it is just a container or just a process which is there inside a slave node, which is triggered by the master. And this executor process is going to execute your code in the slave node. This is a brief description of what an executor would do. Now, this is just one client mode. There could be other modes. For example, the normal mode which is used in production is called as a cluster mode. And the mode which we normally do for development purposes is called as a standalone mode. We will talk about it later on in detail as and when we see these modes in picture. With this thought, let's continue to the code. So let's run the first piece of code and see what we are doing here. So first of all, I need to have a data for analysis. So the environment, what I'm using here is Databricks. Databricks is a distributed kind of an environment, but just for testing purposes, I have created a cluster, which is a standalone cluster. That means I will have only one node, which is a 14 GB memory and 4 core node. This one single node does the function of driver, it does the function of executor, everything is within one single node. Now, when I run this program, I need to have some data set. Now my data set is present in file store and ASC data. Now, where is this folder? This folder is basically here. So Databricks has its own file system, which is called as DBFS, which can be accessed in the Data Explorer. So you go in the file store, and then in the file store, you see NYSE data. And all these are my data files. So I have text data or a CSV data, and it is compressed using GZ format. In this command, I'm trying to read this data which is present in NYSE data folder. The data format is CSV, and I'm trying to do something called as infer schema. By that, I mean that I do not know the data type of the different columns, and I want Spark to understand the data type of the columns by itself. So what Spark would do, it would go to the columns and sample out the data of each and every column and try to figure out whether it is integer data type or a double data type or a string data type. Another important thing to note here is the concept of jobs, stages, and tasks. When I executed this command, I need to see that there are 2 jobs getting created. Now, what is job? What is stage? Let's talk about it as we see the logs screen of Spark UI. So when you go to the cluster, which is here, there's something called a Spark UI. Now I've opened the Spark UI separately. So when I ran this command, in Spark UI, I saw 2 jobs getting submitted. These are the 2 jobs. As you can see, the time is same for both of them. So 11:44:25. So these are the 2 jobs that got executed when I executed one single command. The only job that we are going to concentrate out of these two is the first job. So let's open the first job, which has 4 tasks. You see here, there's a tasks column, which has 4 tasks. So let's open this job. Inside a job, there will be multiple stages. For example, this is one stage. So that means in this job number 8, there is only one stage present. Now within the stage, there can be multiple tasks. Now this is the DAG of a stage. The only thing that you need to see as of now is it's a text scan. So that means you're getting the data from a CSV file. And you can see there are 4 different tasks here. The question comes is why 4 different tasks and why not 3 or 2? That's because the cluster or the node that you have is having 4 cores, as we saw in the cluster configuration. So if you go to compute, you see the cluster configuration here. It would have 4 cores. One core can do one task by itself. So that means there can be 4 parallel tasks that can be executed at one point of time. So that is the reason that you see 4 different tasks. Now, what are these 4 tasks? Think about your command. Your command is trying to read the data. When it is trying to read the data, which is, let's say, maybe 500 MB, what it will do is it will tell all its cores to read the data in parallel. So that means one core will read 100 MB, second core will again read 100 MB. Same way, the reading part of the data frame or the data will also get distributed. So that's why you see 4 different tasks, because 4 different cores available within that node. So important concept to note here is one statement. This is your one statement. It can trigger one job or more. In your case, it triggered 2 jobs. One job was for reading the data from this folder, which we saw in detail now. The second job is to infer the schema. Now, the second concept is one job. Each job can have one or many stages. In our case, it was only one stage. And then one stage can have one or many tasks. In our case, we saw that one stage was having 4 different tasks. With this, let's move on to the next step. I will skip this command because there is nothing much that I'm doing here. It's just a renaming of the column, so nothing great. In the next command, there is something called as column expression and SQL expression. Now, what is column expression and SQL expression? There are many things that we can code in Spark, or there are many concepts that we can code in Spark that can be done in 2 different ways. For example, we can apply filtration. That means we can do a where clause. There are 2 ways to do this filtration. One way is using a SQL-like query, which is here, date is equal to this, short name like this. This is a SQL-like query. Another way is a column expression, which is the second one, which you see here, which uses a function called as COL, which is from PySpark SQL.functions. So for rest of the sessions and for this session also, I'm going to concentrate primarily on SQL expression because that's what I'm comfortable with. It's your choice, whatever you're comfortable, you can use that. Now, another thing that we need to notice is something called as lazy evaluation. Before trying out lazy evaluation, let's open the jobs page. Now, if you see on the jobs page, the last job that got submitted was something to do with df1.column renamed, right? So we did this job, df1.with column rename. After this, we have not done anything. Now, important thing to note is when I execute the next command, which is the where clause, and check out the jobs, see the last job ID is number 9 as of now. We need to see if the number of jobs increase. It does not increase, right? Why? We have executed a command, but the job numbers don't increase. That's because of the lazy evaluation feature of Spark. What is lazy evaluation? What Spark does, it distributes your entire piece of code into 2 parts. One is called as a transformation. One is called as an action. Unless and until Spark sees an action, it won't execute the transformations. So how your code looks like? Your code looks like transformation 1, transformation 2, transformation 3, and then action. And then let's say transformation 4, transformation 5, and then let's say action. So transformation 1 could be, let's say, a where clause. Transformation 1, 2 could be another filtration. Transformation 3 could be another group by. Till I execute an action. So action could be a display command. Till I execute the command display of T3 of df after T3, any of these commands or none of these commands have got executed till the time I execute a display or I do an action here. Once I do an action, all these commands are getting executed. So it basically tries to break your code into actions. So once it gets an action, it executes everything before this. Again, T4 comes, T5 comes, even though you feel that it is getting executed, it is not. Once it sees an action, let's say collect is an action. We are going to talk about this statement later, but as of now, collect is an action. As soon as you launch collect command, T4 and T5 both gets executed. So that was the concept about transformations and actions. Now, important thing to note here is we were talking about lazy evaluation, right? So lazy evaluation means that you don't do transformations as and when they come into the code. But you execute the code when you see an action, right? So that's lazy evaluation. So that is the reason we did not see any number of jobs getting increased when we executed this command df.where, because it is a transformation, and for a transformation, it is not executed unless you see an action. In the next cell, I have an action, which is display. As soon as I get an action, the number of jobs are going to increase. Let us see in the job. So as of now, job number 9 is the latest one. You see here, the number of jobs increase. So basically, the command which was not executed for the transformation got executed now when I triggered the action. So that was about lazy evaluation and transformation and actions. Now let's talk about a brief concept called as immutability. Data frames in Spark are immutable. That means when you derive one data frame from another, they both will have different object ID. For example, you do a transformation here. So your df2 SQL is derived from df1. So both df1 and df2 SQL are two different objects. You are not overwriting df1. This can be proven when you follow this command. As you can see, both of these objects, df2 SQL and df1, they both have a different object ID, 44 and 50. So they both are different objects, and data frames in Spark are immutable. Next, we have to talk about a very important concept called as filter pushdown. Now we have a data frame called as df2 underscore SQL, right? Now df2 underscore SQL has this data. You have a short name, date, and stock value. Now what is this data set? This data set is just yours. Let's assume it is NASDAQ data, right? You have all these stocks which are listed on NASDAQ, and this data talks about the date and the corresponding stock value. So for example, AAC is a stock name, stock short name. On 1st of January 2016, the stock value by end of the day was $1906, right? Next, we have this data set with us. Now we only want to see the data corresponding to 2016 and 1st of January. So we do a filter clause. When we do a filter clause, something interesting happens. When we look at the explain plan, we see here that there is something called as pushed filters. And you can see it has the value 2016-0101. So what do you mean by pushed filter or a filter pushdown? So a filter pushdown is that you're utilizing the power or the energy of the backend to actually execute your code. So that means your filter clause will first get executed in the backend, and then only the result will be fetched in Spark. So this is a push down concept. In the other case, Let's assume that filter is executed within Spark and not in the backend. In this case, no pushdown is happening. So in our case, we saw the explain plan. There is a filter called as 2016-0101 and it is pushed down to the backend. Now with this, let's move forward. We are going to again come at the concept of filter pushdown. So please try to remember this. We will again revisit it in the same session. The next concept, we are trying to explicitly define the schema of the data file. Now we know that the data file had a stock name, which was string. It had a date, which was actually coming as an integer, and it has a stock value, which was coming as float or double. Now date value was coming as an integer and stock value as double. This is an important thing to note. So date value 2016-01 was an integer and 1906, the stock value was a float. So what do? We define the schema explicitly saying that the date value should not be an integer, it should be date type. And the stock value should not be double, it should be string. I know it is incorrect to say it is string, but let's just go ahead with the flow. There is a concept that I want to explain using this string stock value. That's why I have written this as a string data type for a numeric column. So the next command, we are reading the same data again. We are reading a CSV from this file. Instead of inferring the schema, we are using our hard-coded schema. And then once we load the data types of the new data frame are different. Date has a data type date type, and stock has a data type string. This can also be seen in the below picture. Let me execute it again. And you can see in this picture, the date has got converted to a date type. You can see it's more of a date format now. Initially, it was 2016-0101. The hyphens have come in now. So it looks like a date format now. And your stock value is a string, even though it looks double. The next thing that we need to see now is the filter pushdown that I was telling that we will revisit it. So now if I launch this command, we do a where clause, we do a stock value greater than 50. Now if we do it, and we see filter pushdown, we do not get the filter stock value greater than 50 in our pushdown filters. Rather, stock value greater than 50 is getting filtered in Spark, as you can see in the highlight. So this means in this specific case, what had happened is your filter was not done in backend. All data was retrieved by Spark, and then filtration was done in Spark. This is an added burden for Spark. Spark had to do the filtration, but why? The reason is simple. The stock value column was a string column because we have defined an explicit string data type for stock value, as you can see here, right? So that is the reason the backend could not do any filtration, because backend felt that it is a numeric column, but you have defined a string data type. So backend got confused and it pushed all the data to your front end. And then finally Spark had to do the filtration for stock value equal to or greater than 50. So that's all for today, guys. Have a good day. We'll meet again in session 2. Bye-bye.